Somewhere far from the coast, after the last light has left the sky, the ocean seems to become simple. The surface darkens, the waves lose their color. From a ship or a quiet beach or a window looking out over black water, it can feel as if the sea has gone still with the rest of the world. But beneath that dark surface, the night is beginning to move. While cities dim their lights and bedrooms grow quiet, the ocean below is filling with hidden motion. Tiny animals rise through the water. Fish follow them. Squid drift upward from dimmer layers. Predators begin to search. In the darkness, creatures that would hide by day enter the open water under the protection of night, joining one of the largest daily movements of life on Earth. And deeper still, beyond the reach of moonlight, the meaning of night begins to change. There are places in the ocean where sunlight never arrives, where darkness is not a few hours between sunset and dawn, but a permanent condition. Yet even there, the deep sea is not sleeping. It is listening, feeding, glowing, waiting, and changing in ways most of us will never see. This is a journey into that hidden world. We will follow the sea from the quiet surface down into the twilight zone, where life rises and falls with the night. We will enter the black water, where living lights flash like signals in a language older than human speech. We will watch food fall slowly from the sunlit world above, and we will descend to the seafloor, where a single whale body can become an entire temporary ecosystem. Farther down, we will find places where life does not wait for sunlight at all, but gathers around heat minerals and chemistry rising from the earth itself. And in the darkness, we will learn that the deep ocean is not silent. It has voices, vibrations, calls engines, currents, and distant sounds moving through water more easily than they ever could through air. So tonight, as the surface world rests, we are going below it. What happens in the deep ocean when the world is asleep? And what does that hidden darkness reveal about the living planet beneath our feet? Long after sunset, when the last colors have drained from the sky, the ocean can seem almost motionless from far away. A beach that was bright and restless in the afternoon becomes a darker edge of the world. The sand cools. The air softens. The horizon loses its sharp line until sea and sky begin to blend into one wide breathing shadow. From land, this is the hour when people start turning inward. Windows glow for a while, then go dark. Streets empty. Boats return to harbor, their engines fading into the distance. Even the waves can begin to sound slower, as if the whole world has lowered its voice. But the surface of the sea is not the whole ocean. Beneath that dark water, the first changes of night are already passing downward. The sun has disappeared, but its absence is not empty. It alters light temperature risk and movement. It changes what can be seen, what can hide, what can feed, and what can safely rise. To human eyes, the ocean surface at night may look like a quiet sheet of black glass. Yet the upper layers of the sea are entering one of their most important daily transitions. During the day, sunlight pours into surface waters, feeding microscopic plants called phytoplankton. These tiny drifting organisms are too small to notice from above, but they help form the base of the ocean's food web. Where there are phytoplankton, there are grazers, tiny animals, larvae, copepods, krill, jelly-like drifters, and countless other forms of plankton move through the water, feeding, avoiding being eaten, and responding to light, in ways that seem simple only because the animals are small. Their lives are measured in currents, shadows, chemical traces, and the shifting danger of visibility. In daylight, light is both gift and threat. It allows photosynthesis near the surface, filling the upper ocean with energy. But it also exposes bodies, A creature suspended in clear water has nowhere to hide if a predator can see its outline from below or above. So, for many small animals, the bright upper sea is dangerous during the day. Some stay deeper, wading in dimmer water where they are harder to find. They do not sleep as humans sleep, and they do not plan in any human sense. But their bodies respond to patterns older than memory light, above shadow, below, hunger, pulling one way, danger, pushing another. As evening arrives, the balance changes. The surface loses its brightness first. The water no longer shines from within. The sharp beams that once cut through the upper layers weaken, scatter, and vanish. Blue fades into gray, then into black. For small animals, wading below the darkening surface becomes less dangerous. This does not happen all at once. Night enters the sea, gradually passing through the upper water, like a curtain lowering in slow motion. A few meters down, then many meters down, the world becomes dimmer. The difference between hiding below and feeding above begins to narrow. In these first hours after sunset, the ocean begins to loosen. Small bodies rise. Some drift upward, almost invisibly carried by tiny movements and weak swimming. Others pulse, flick spiral, or beat delicate appendages against the water. A creature no larger than a grain of rice may begin a nightly journey that, in proportion to its body, is immense. The surface still looks calm. The waves still lift and fall. A person standing on a dark shore would see only the moon path, if there is a moon at all, and perhaps the reflection of stars broken by ripples. But under that surface, the water is becoming crowded with intention. The first motion is not dramatic. It is more like a silent rearrangement. Tiny grazers move upward toward the rich upper layers where food waits. They come because darkness gives them cover. They come because the sunlit world has spent the day making life, and night allows other life to feed on it. This is one of the ocean's great hidden rhythms. It does not need a storm, a tide, or a visible sign from above. It begins with the daily turning of the planet away from the sun. As land falls asleep, the sea opens a passage. Near the surface, the water itself is changing. During the day, sunlight warms the upper layer, especially in calm weather. At night, some of that heat begins to leave. The air above the water may cool, and the skin of the sea can lose some of the warmth gathered through daylight. In some places, gentle mixing begins to blur the boundary between the surface and the water below. These physical changes are subtle, but in the ocean, subtle changes matter. A small shift in temperature can influence where plankton gather. A change in wind can disturb the surface and mix nutrients. A darker sky can make the difference between being seen and surviving another night. The ocean does not have one single night. A cloudy night is different from a moonlit night. A clear night over the open Pacific is different from a coastal night filled with harbor lights. In polar seas, night can last for months. In tropical waters, sunset can come quickly, and the daily rhythm can feel sharper. Yet across much of the planet, as darkness spreads over the sea, the same general pattern begins. The upper ocean becomes safer for creatures that avoided daylight. Food near the surface becomes reachable. Predators that depend on darkness begin to move. The sleeping human world rests beside a water column quietly filling with life. It is easy to imagine the deep ocean as separate from this surface scene, as if the black water below belongs to another planet. But the deep sea is tied to the surface more intimately than it first appears. What happens in the upper ocean does not stay there. Hunger wastes bodies, particles, and movement all connect the bright skin of the sea to the darkness underneath. Even the smallest organisms near the surface belong to a much larger story. A drifting phytoplankton cell may be eaten by a tiny animal. That animal may be eaten by a fish. The fish may descend or be swallowed, or leave waste that sinks slowly through the dark. A moment of feeding near the surface can become part of a downward journey that lasts long after the night has passed. This is why the quiet surface is deceptive. It is not a lid over an empty depth. It is the beginning of a chain. On some nights, the surface reveals a hint of this hidden life in brief flashes. A wave breaks and glows faintly. A boat wake burns blue-green for a few seconds before fading. A footstep in wet sand can disturb tiny luminous organisms and make the shore glitter as though stars have fallen into the foam. These lights are not magic, although they often feel that way. They come from living organisms, many of them small, responding to disturbance. Near the surface, certain plankton can produce light when moved or threatened. Their glow may startle predators, attract larger predators that might attack the attacker, or simply mark the motion of water in a way that human eyes find beautiful. For a listener on shore, such flashes seem like decoration, but they are the first visible hint of a much deeper truth. In the ocean, darkness does not always hide light. Sometimes, darkness is what allows light to be seen. Still, most of the night's activity remains invisible. The greatest changes are happening not on the wave crests, but in the water below them. In the first 100 meters, then deeper, the ocean becomes a layered space where every animal must solve the problem of being alive in 3 dimensions. On land, night spreads across surfaces, streets, forests, rooftops, fields. In the sea, night fills volume. It does not only darken the top of the world, it opens depth. A fish does not simply move forward or backward. It can rise, sink, hover, turn, vanish into dimmer water, or follow a trail of smaller life upward. A squid can wait below the level where it is easily seen, then ascend under darkness, with eyes tuned to faint changes in light. A gelatinous predator can hang almost transparent in the water, waiting for something smaller to drift too close. The ocean at night is a vertical landscape. There are no paths in it yet. Bodies follow roots. There are no doors yet. Darkness opens and closes possibilities. The same water that seemed empty at dusk becomes a passage between layers of risk and reward. For many creatures, the surface is not home. It is a feeding ground visited under cover. They come upward because the upper ocean is richer, but they cannot remain there safely once daylight returns. Their lives depend on timing, on the slow clock of light changing above them. This is where the idea of a sleeping ocean begins to fall apart. The sea has no bedtime. It has rhythms. Some are driven by tides, some by seasons, some by currents, some by the moon, and some by the daily disappearance of the sun. To mistake darkness for rest is to see the ocean only as scenery. At night, even the boundary between air and water feels altered. The surface reflects less of the sky and reveals less of itself. The blackness gives the impression of depth, but not its details. It is like looking at a closed eye and forgetting that thought continues behind it. Below, life is making decisions without words. Stay low, rise now, follow the food, avoid the silhouette, wait for deeper darkness, drift with the current, flash and vanish, hide before dawn. No single mind directs this. There is no command moving through the water. The pattern is made by countless separate lives responding to the same planetary signal. Sunset does not order them upward. It changes the conditions, and life answers. That answer is older than human sleep, older than ships, older than cities glowing along the shore. It has been happening through ages of changing coastlines, shifting climates, vanished species, and oceans that have never once been still. Every night, the planet turns light, leaves the water, and hidden life begins to rearrange itself. For humans, night often means retreat. We close curtains, we lower our voices. We leave the visible world and enter rooms, dreams, and darkness. But in the ocean, darkness can mean arrival. It can mean the opening of a feeding ground and the beginning of a climb. The first animals that rise do not know they are part of something vast. They do not know that scientists will one day lower instruments, send out sound waves, study scattering layers, and realize that the ocean itself seems to shift at night. They simply move through the water because their bodies have learned the terms of survival. Above them, the moon may be bright or hidden. The stars may reflect in broken silver across a swell. A seabird may pass low over the water. A ship may cross the dark with a soft engine hum, unaware that beneath its hull, an immense migration is beginning to gather. This is the threshold of the deep ocean's night. We are still near the surface, still close enough to imagine the world above us. But already the familiar meaning of darkness is changing. It is no longer only an ending to the day. It is a signal passing through water, calling small lives upward, drawing predators after them, and linking the quiet surface to the depths below. Soon, that hidden upward movement will become too large to think of as scattered motion. It will become a living tide, a nightly ascent through the water column, a migration so vast that it can be detected by sound and yet remain unseen from shore. The surface has gone quiet. Now the ocean below begins to rise. Below the quiet surface, the rising begins almost without shape. At first, it is only scattered motion in the dark. A copepod beats its tiny limbs and moves upward through the water. A small shrimp-like animal leaves the dim safety below and climbs toward the richer layers above. A larval fish, almost transparent, drifts and corrects itself, drawn into the same slow ascent as thousands of other bodies around it. No one standing on the shore would see this. No moonlit wave would announce it. The ocean would still look calm, almost empty, as if night had covered it with a single black sheet. But inside the water column, the blackness is filling with travelers. This is the nightly migration of the sea, a movement so large that it is often described as one of the greatest daily migrations of animals on Earth. It is not a migration across continents, like birds following the seasons, or herds crossing grasslands under a wide sky. It moves vertically through depth. It happens in layers of water, under darkness, with no visible road, and no sound the human ear can easily hear. For many of the animals taking part in it, the journey begins in the twilight zone, that dim middle world below the bright surface and above the deeper black. During the day, they remain lower, where sunlight is weak enough to hide them from many predators. As night falls, they rise toward the surface to feed. The reason is simple, but the pattern is vast. The upper ocean is where sunlight has made food. Microscopic plants grow there. Tiny grazers feed there. Life gathers there in richer concentrations than in the colder, darker water below. But the upper ocean is also dangerous by day. In sunlight, even a small body can become a target. A fish looking upward may see the shadow of prey against the brightness. A predator looking downward may detect movement, reflection, or outline. For creatures that are small, soft, or lightly armored, visibility can mean death. So they wait. They wait below the brighter water until the light fades. Then as darkness spreads downward, the risk changes. The surface does not become safe exactly. It becomes possible. The night gives cover, and hunger gives reason. The first climbers are followed by others. Small grazers rise to feed on phytoplankton and smaller drifting life. Larger animals follow the grazers, lanternfish squid, small crustaceans, jelly-like hunters, and many other creatures enter the nightly traffic of the water column. Then come the predators that hunt them, moving through the same darkness with larger eyes, sharper senses, and bodies built for sudden motion. The ocean becomes a highway without lanes. Some animals rise only a short distance. Others travel hundreds of meters. Some make this journey every night of their lives, climbing upward after dusk, feeding in the dark, then sinking again before the dawn makes them visible. Their entire existence is shaped by this rhythm of ascent and retreat. For a human body, such a journey would be impossible without machines. The pressure changes alone would be dangerous, and the cold would be overwhelming. But many marine animals are made for this vertical world. They do not experience depth as an alien place. It is the space through which their lives are written. Imagine for a moment a small lanternfish suspended in dim blue darkness. During the day, it remains below the brighter surface, part of a loose, hidden layer of life. Its body is small, but its role is large. It feeds on smaller organisms, and it is eaten by larger ones. It carries energy between worlds that seem separate from above the sunlit surface and the darker sea beneath. As night arrives, the lanternfish rises. It does not rise alone. Around it, countless other animals are also moving. The water seems empty because the human eye cannot hold the scale of what is happening there. But instruments can detect these layers of life, and sometimes sound waves sent into the ocean bounce back from the bodies of animals gathered below, revealing a moving band that shifts upward at night and downward at dawn. Long before scientists understood what they were seeing, these scattering layers must have seemed strange. Something in the water appeared to move like a false bottom. It could rise, sink, thicken, vanish, and return. The seafloor itself was not moving, of course. Life was. This is one of the quiet wonders of the ocean. A hidden living layer can be so dense and yet so invisible that it takes instruments to notice what has been happening every night beneath the waves. The migration is not perfectly uniform. The sea does not behave like a machine. Moonlight may keep some animals deeper. Cloud cover may change how safe the surface feels. Storms can disturb the upper water. Predators may alter the movement of prey. Different species rise at different times to different depths for different reasons. Still, across huge areas of the ocean, the pattern repeats with astonishing persistence. As the world darkens, life climbs. Before the world brightens again, life sinks. This nightly climb is a feeding event, but it is also a survival strategy. To feed an animal must risk exposure. To survive, it must not remain exposed too long. The vertical migration is a compromise between hunger and danger, repeated so often that it becomes one of the deep rhythms of the planet. For the smallest animals, the journey may feel nothing like a journey. A tiny zooplankton does not know that it is moving between ocean layers. It follows light pressure, chemical signals, internal clocks, and inherited patterns of behavior. It responds to the world as its kind has responded for countless generations. But when millions upon millions of small responses gather together, the result becomes enormous. The migration draws energy upward and downward. Animals feed near the surface at night, then carry some of that energy back into deeper water when they descend. They breathe, release waste shed tissue, die, and are eaten. In doing so, they help move carbon and nutrients through the ocean, linking the dark sea to the atmosphere and the sunlit world above. This is where the night migration becomes more than a hidden spectacle. It becomes part of Earth's work, A tiny animal feeding near the surface is not only feeding itself, it may become food for a fish that descends. That fish may become prey for a squid. Waste from that squid may sink as a particle. A dead body may drift downward through colder water. Each movement, each feeding, each loss becomes part of the ocean's slow exchange between surface and depth. The deep ocean depends on such exchanges. It is not cut off from the light above. Even in darkness, it receives traces of sunlight, secondhand, passed through bodies, waste particles, and prey. The nightly migration is one of the ways the upper ocean and the deeper ocean remain in conversation. For the animals themselves, though, the night is immediate. There is no planetary calculation. There is only the dark, the food, and the need to avoid becoming food. A squid rising through the water does not move like a fish. It pulses and glides its body, changing shape as it climbs. Its eyes are tuned to faint light. Its arms are ready to seize smaller prey. It may itself be hunted by larger fish marine mammals or deeper predators waiting in the layers above and below. A jelly-like predator may move with almost no urgency, drifting through the migration as if the water itself were carrying it into place. Its tentacles trail in the dark. A small animal that touches them may be caught before it understands the danger. In this world, speed is only one form of survival. Patience is another. The migration is full of such different strategies. Some animals are transparent, almost vanishing in the water. Some are dark red or black colors that disappear quickly in dim light. Some are reflective, breaking up the outline of their bodies. Some carry rows of light-producing organs, not to announce themselves, but to control how they appear in the darkness. Here the boundary between hiding and shining becomes complicated. A small fish in the twilight zone may use faint light along its body to match the glow from above, making its silhouette harder to see from below. A squid may flash and vanish. A jellyfish may release light when disturbed. The same darkness that protects one animal may become a stage on which another animal sends a signal. But before we enter that language of light, it is worth staying a little longer with the movement itself. There is something almost dreamlike about a migration that happens without footsteps, wings, or dust. On land, migration often leaves marks trails through grass tracks in mud flocks, crossing the sky herds gathering at rivers. In the ocean, the passage closes behind every body. The water keeps no visible footprint, and yet night after night the journey is real. The migrants rise through pressure, cold, and darkness. They pass through layers where the temperature shifts, where the water holds different amounts of oxygen, where currents slide over one another like invisible weather. They move through a world that is never still, even when it seems quiet from above. Some are eaten before they reach the surface. Some feed and survive. Some never return to the depth from which they came. Others descend again before dawn, carrying their meal into darker water, leaving the surface once more to the day. As dawn approaches, the whole pattern begins to reverse. Before humans on shore see the first clear line of morning, many animals have already begun their retreat. They move downward as the light returns, leaving the upper ocean to brightness and danger. The same water that held them through the night begins to empty, at least to human imagination. The surface becomes blue again. Sunlight spreads across it. Birds may feed. Boats may move out from harbor. People may wake, stretch open doors, and look at the sea as if the day has just begun. But the ocean's night has already done its work. The feeding has happened. The pursuit has happened. Energy has changed bodies. Carbon has begun new downward paths. Predators have eaten prey, have escaped, and the living layers of the water column have shifted back into the dimness below. This daily reversal gives the ocean a pulse. Not a heartbeat in the literal sense, but a recurring movement of life between risk and refuge. upward under darkness, downward before light, hunger rising, safety sinking. The pattern is simple enough to understand, but vast enough to remain almost unimaginable. And still, this is only the upper part of the story. The Great Migration shows us that night can move through the ocean like a signal. It tells us that darkness changes behavior, not just appearance. It opens a temporary world near the surface, then closes it again with dawn. But as we descend farther beyond the layers that rise and fall each night, we enter a different kind of darkness. There, the sun does not return in the morning. Their animals cannot wait for daylight to fade, because daylight never arrives. They must find food mates and safety in a world where vision has changed its meaning. They must hide in darkness, hunt in darkness, and sometimes speak through darkness with light made by their own bodies. The night migration has carried us away from the sleeping shore and into the living water column. Now the dark ahead begins to flicker, not with stars above the sea, but with living lights inside it. The dark ahead does not stay completely dark. At first, there may be only a single flash so brief that it seems almost imagined. Then another appears farther away, a small green spark, opening and closing in the black water. A faint pulse moves across the body of a drifting creature. A line of tiny lights glimmers along the underside of a fish, then disappears as if the ocean has swallowed its own stars. To human eyes, these lights can feel like wonder. They look delicate, unreal, almost decorative. But in the deep ocean, light is rarely decoration. It is information. It can attract, warn, confuse, hide, frighten, invite, or betray. In a world where sunlight fades and then vanishes, living light becomes one of the ocean's most important forms of survival. This light is called bioluminescence, the production of light by living organisms. It happens when chemistry inside a body releases energy as light, often with very little heat. Fireflies use a version of this on land, but in the ocean, the phenomenon becomes far more widespread and far stranger. Many creatures in the water column are capable of producing light, from tiny plankton to jellyfish, from squid to fish, moving through the black midwater. The deeper we go, the more important this ability becomes. Near the surface, sunlight dominates everything. In the shallows, colors can matter, shadows can matter, and the bright world gives many animals enough light to see and be seen. But as depth increases, red disappears first, then orange, then yellow. The world becomes blue, then dim blue, then a darkness so complete that ordinary vision begins to lose its old purpose. Yet even there, the ocean is not blank. It is filled with controlled moments of light. A flash in the dark may last less than a second, but it can change the fate of the animal that makes it. It may startle a predator long enough for escape. It may draw prey closer. It may signal to a mate of the same species. It may break up the outline of a body, making it harder to see from below. It may call attention in one direction, while the animal itself escapes in another. The deep ocean does not use light in one way, it uses light in many. Some animals glow from organs arranged along their bodies, like small lamps. Some release glowing clouds into the water. Some carry bacteria that produce light for them. Some flash only when touched. Some shine steadily with a faint blue-green glow matching the dim illumination from above so that their bodies almost disappear. This last strategy is one of the most elegant forms of hiding in the sea. In the dim upper darkness, a predator looking upward might see the silhouette of prey against the faint light filtering down from the surface. To avoid becoming a shadow, some animals produce light from their undersides. If the brightness is just right, they blend into the glow above them. They hide by shining. This is called counter-illumination, but the word is less important than the image. Imagine a small fish suspended in deep blue darkness with a faint silver-blue light along its belly. It is not trying to be bright. It is trying to erase the difference between itself and the water above. The light that could reveal it becomes the light that conceals it. In the deep sea, survival often depends on such reversals. Darkness can protect, but it can also isolate. A creature that cannot be seen by predators may also struggle to find food or a mate. To live in darkness, an animal must manage the problem of being visible and invisible at the right times. It must hide from some eyes while becoming noticeable to others. This is why bioluminescence feels less like a spectacle and more like a set of precise signals. A jellyfish disturbed by a passing animal may send rings of light racing across its body. The display may startle the attacker, but it may also attract something larger, something that might attack the predator itself. In that brief flash, the jellyfish changes the situation. It turns a private attack into a public announcement. A squid may use light more subtly. Some squid can alter patterns on their bodies, flashing dimming or shifting appearance as they move. In darkness, these changes may help them communicate confused prey or avoid being recognized too clearly by predators. Their bodies become surfaces of moving signals written in light and erased almost as soon as they appear. Then there are the hunters that use light as invitation. The anglerfish is the most familiar example, although familiarity has made it easy to misunderstand. It is often shown as a monster with a glowing lure, waiting in darkness for prey to come close. That image is not entirely wrong, but it can become too simple. The anglerfish is not a monster. It is an animal shaped by an environment where energy is scarce, encounters are rare, and a small mistake can mean the difference between feeding and starving. Its light is a tool of patience. In the black water, a glowing lure may resemble food or motion or something alive enough to investigate. A smaller fish or crustacean comes closer. The anglerfish waits until distance disappears. Then the mouth opens and the darkness closes around the prey. This is not drama in the human sense. It is economy. In a world where meals may be rare, the ability to bring food within reach can be life itself. Other lights warn instead of inviting. Some animals flash when attacked, creating sudden brightness where a predator expected darkness. Some release glowing material into the water, leaving a luminous decoy behind while the body escapes into blackness. The predator lunges toward the light, and the animal that made it is no longer there. Light becomes misdirection. Even tiny organisms near the surface may use light defensively. When disturbed by waves, fish, or a moving hand in water, some plankton produce brief blue-green flashes. To us, the effect can seem beautiful, like sparks in the surf. But for the organism, the flash may be part of a survival response, a way to make disturbance visible and possibly draw attention to the disturber. Beauty in the ocean is often a side effect of function. This matters because human beings tend to read deep-sea light emotionally. We see mystery magic, loneliness, or alien beauty. Those responses are understandable. They are part of why the deep ocean grips the imagination. But the animals themselves are not performing for wonder. Their lights belong to hunger, fear, recognition, confusion, and reproduction. The dark ocean is filled with practical miracles. One of the most difficult things about studying this light is that the act of looking can change it. A bright light from a submersible or remotely operated vehicle can frighten animals away, overwhelm their own signals, or reveal creatures that normally live in darkness. The deep ocean does not behave naturally under a human spotlight. So, scientists have had to learn patience. They use low-light cameras, red, light, careful observation instruments, lowered into darkness, and vehicles designed to disturb the water as little as possible. Even then, what we see is only a fraction of what is happening. The black water may be full of signals just beyond the range of our instruments, our timing, or our understanding. To enter the world of bioluminescence is to enter a place where the ocean keeps many of its meanings brief. A flash appears, and then it is gone. Was it a warning? A lure? A mating signal? A startled response? A form of camouflage breaking for a moment? Without context, even a visible signal can remain unread. This is part of the deep sea's mystery. It does not only hide things because it is dark, it hides meanings because its signs belong to other bodies, other senses, and other needs. For an animal living there, the darkness is not blank. It is textured with faint changes. A small movement in the water, a pressure wave, a chemical trace, a weak glow above a pulse of light nearby, these may all matter. The world is not seen all at once as humans see a landscape. It is sensed piece by piece. In that world, eyes can become enormous, or they can shrink almost away. Some animals rely on vision tuned to faint light. Others live so deep or in such darkness that sight becomes less useful and other senses take over. But where bioluminescence is common, eyes still have work to do. They do not look for daylight. They look for living signals in the black. A flash can mean prey. A flash can mean danger. A flash can mean another of your kind. This last possibility may be one of the most quietly powerful. In the open ocean, especially at depth, animals can be widely scattered. The darkness is not only dark, it is vast. Finding a mate may be incredibly difficult. A pattern of light, a particular rhythm, a location on the body, or a faint glow at the right moment may help one creature recognize another in the immense black. Survival is not only about eating and escaping, it is also about being found by the right one and missed by everything else. That balance gives deep sea light its emotional weight. It is not simply a glow in darkness. It is the tension between exposure and connection. To be seen can be dangerous. To never be seen can be just as fatal. The same contradiction exists across much of the deep ocean. Animals hide, but they must hunt. They vanish, but they must communicate. They conserve energy, but they must act when the rare chance arrives. Bioluminescence lets them enter that contradiction with precision, using tiny amounts of light in a world where light is powerful because it is scarce. For the listener drifting downward through this documentary, the lights may feel like stars. But unlike stars, they are near. They are not burning suns far beyond reach. They are bodies, chemicals, organs, bacteria, and signals made in cold water. They appear for reasons. A row of lights may smooth a silhouette. A glowing lure may imitate life. A sudden flash may startle danger away. A blue cloud may hide an escape. A faint pulse may say, "I am here, but only to the one who knows how to read me." The more we understand this, the less the deep ocean feels empty. It becomes crowded with signals. Not signals for us, but signals moving between creatures that have never known sunrise, firelight lamps, or cities. Their world was lit before we invented light. Long before humans lowered cameras into the sea, before ships crossed the surface, before language itself, animals were already flashing beneath the waves. Their signals came and vanished in the black water, unnoticed by the world above. Even now, while houses grow quiet and people sleep, that flickering continues. Somewhere below the surface, a jellyfish flashes when touched. A fish dims itself against the faint glow overhead. A squid passes through darkness with patterns flickering across its body. An anglerfish waits its small light, suspended in the black, like a question. Around them, all the ocean remains vast enough to hide most of what happens there. Living light changes our understanding of the deep. It shows that darkness does not end communication. It transforms it. It turns light into something brief, exact, and sometimes dangerous. But light alone cannot explain how this world survives. Every flash, every movement, every patient hunter, every drifting body requires energy. In the sunlit ocean, energy begins with photosynthesis, with tiny plants using sunlight near the surface. But down here, beyond the reach of the sun, no forests grow, no grass spreads, and no bright fields of plankton bloom. So another question begins to rise through the dark. If so much life moves, hunts, glows, waits, and signals in the deep ocean, what feeds it? The answer is not a single event, but a slow descent. From the bright world above, through the layers where migrants rise and fall, tiny remains begin to sink. They fall silently through black water, piece by piece, body by body, particle by particle. The lights fade behind us. Ahead, the deep ocean waits for its quiet reign. Beyond the living flashes, beyond the brief signals that open and close in the dark, another movement is always happening. It is quieter than the nightly migration. It is slower than the pulse of a squid, slower than the sweep of a fish through black water. It does not hunt, shine, call, or flee. It simply falls. From the sunlit ocean above, tiny pieces of life begin their descent. Dead plankton, fragments of shells, waste from animals that fed near the surface, bits of mucus dust, soot, sand, and drifting organic matter gather together in small, pale flakes. Suspended in the water, they sink so gently that they can look almost weightless. Scientists call this marine snow. The name is delicate, and in some ways it is exactly right. In the beams of a deep-sea vehicle, these particles can appear like a soft snowfall passing through darkness. They drift downward in silence, turning and tumbling in the water, each flake carrying some remnant of the living world above. But this snow is not cold weather, it is food for the deep ocean where sunlight cannot grow plants, and meals are often scarce. The falling remains from the upper sea are one of the great sources of survival. The abyss is not fed by fields, forests, or daily sunlight. Much of it is fed by what the bright ocean produces, uses, sheds, and loses. A plankton bloom near the surface may begin with sunlight. Tiny plants draw energy into their bodies. Small animals graze on them. Larger animals feed on the grazers. Waste is released. Bodies die. Shells break. Gelatinous forms collapse. What is not eaten immediately may begin to sink. And as it sinks, the deep ocean receives the surface world in pieces. This is one of the most important connections in the sea. The bright upper ocean and the dark deep ocean can seem like separate realms, but they are joined by a constant downward exchange. Life above becomes food below. A moment in the light becomes a particle in the dark. Not every particle reaches the deepest water. Many are eaten on the way down. Bacteria break them apart. Small animals nibble at them. Some dissolve, fragment, or become trapped in other layers. The descent is not a simple fall from surface to seafloor. It is a long passage through mouths, microbes, currents, chemistry, and time. Still enough sinks to matter. Imagine a single flake of marine snow beginning its journey in the upper ocean. It may contain the remains of many tiny lives bound together in a fragile cluster. It leaves the sunlit layer and passes into dimmer blue water. Around it, small swimmers and drifting animals may detect it as food. Some take pieces from it. Others ignore it as it continues downward. By the time it reaches the twilight zone, it has already changed. It may be smaller, it may carry bacteria, it may have absorbed other particles. It may be part of a loose shower of organic matter, descending through the same water where animals rise at night and sink before dawn. The deep sea does not receive the surface as a clean gift. It receives it altered, broken, partly consumed, and transformed. That transformation is part of the story. The ocean is not a set of separate rooms. It is a system of exchanges, and the falling snow is one of the ways those exchanges become visible to the imagination. What lives near the surface does not simply vanish when it dies. It enters another economy. In human life, death is often imagined as an ending. In the ocean, it is also movement. A dead plankton cell may become a particle. A particle may feed a drifting animal. That animal may become prey. Waste from that predator may sink farther. A body may fall beyond the reach of light and enter the slow hunger of the deep. Each step changes the form of life, but not the fact that it is still being used. This is why the deep ocean is never completely separate from the day above it. Even where the sun cannot be seen, sunlight is still present in another form. It has been captured by plants passed through bodies and carried downward in matter. The abyss eats sunlight after it has become flesh waste shell and dust. The image is quiet, but the meaning is enormous. Marine snow helps explain how animals can live in places where no plant can grow. A sea cucumber moving slowly across the sea floor may feed on organic-rich sediment, gathering traces of nutrition from what has settled there. A brittle star may lift its arms into the current, catching particles as they pass. Tiny crustaceans may pick through the falling debris. Worms, sponges, corals, microbes, and many other forms of life depend directly or indirectly on the rain from above. There is patience in this world. Much of the deep sea floor is not a place of constant feasting. It is a place of waiting, sorting, filtering, scavenging, and making use of very little. The animals that live there often move slowly because energy is precious. A sudden burst of motion must be worth its cost. A meal may be small, rare, or buried in sediment. The darkness teaches economy. On land, abundance is often visible. Grasslands spread under sunlight. Forests rise into the air. Rivers carry leaves, insects, and fish through open landscapes. In the deep ocean, abundance may arrive as a faint dusting on the seafloor, almost invisible except to the bodies that depend on it. A thin layer of organic matter can mean survival. A slight increase in falling particles can change who feeds, who grows, and who reproduces. A seasonal bloom far above may eventually be felt far below, not as spring sunlight, but as a richer fall of debris into darkness. The deep ocean keeps the memory of the surface, but slowly. Time moves differently in this falling world. A particle may take days, weeks, or even longer to descend depending on its size, density, and the waters it passes through. It may drift sideways with currents pause in layers, be eaten and repackaged, or become part of a larger sinking clump. Its path is not a straight line. It is a quiet wandering. For the listener imagining this descent, the scale can be difficult to hold. The ocean is so deep that even falling has duration. A piece of the upper world may enter darkness long before it reaches the bottom, and by the time it arrives, it may no longer resemble what it once was. Yet the deep knows how to use fragments. A small animal on the seafloor does not need to know where the particle began. It does not need to know the sunlight, the bloom, the drifting plankton, or the chain of feeding above. It finds what has arrived. It gathers filters, absorbs scrapes, or waits for more. This quiet dependence gives the deep sea a kind of vulnerability. If the upper ocean changes, the rain below can change too. If plankton communities shift, if warming alters mixing, if oxygen levels change, If currents move differently, then the food reaching the deep may also be altered. The abyss seems distant, but it is connected to processes unfolding far above it. That connection is also part of the planet's carbon cycle. Near the surface, phytoplankton take carbon from the water as they grow, using sunlight to build living matter. Some of that carbon is eaten and returned quickly to the surrounding water. Some remains in bodies, shells, waste, and particles. When those forms sink, carbon moves downward with them. This is often called the biological carbon pump. The phrase can sound mechanical, as if the ocean were a machine with parts moving in predictable order. But the actual process is more fragile and alive than that. It is made of feeding, dying, sinking, swimming, breathing, dissolving, and being eaten again. It is made of countless small events that together help move carbon from the surface into deeper water. Some of that carbon may return upward later. Some may remain in the deep ocean for long periods. Some may reach the seafloor and become part of sediments. The exact fate depends on depth currents, chemistry, biology, and time. The system is powerful, but not simple. For this documentary, what matters is not to turn the deep sea into a climate diagram. What matters is to feel the connection. The same tiny particles that feed animals in the dark are also part of how Earth moves matter through itself. The deep ocean is not merely receiving leftovers, it is participating in the planet's long circulation of life and carbon. This is one of the reasons the dark ocean matters even to people who never see it. While the surface world sleeps, while cities glow above the coast, and human bodies rest in rooms far from the sea, particles are falling through black water. Carbon is moving, microbes are working, animals are feeding, waste is becoming food. Death is entering another form of life. The process is quiet enough to be missed, but vast enough to shape the earth. And yet for the animals of the abyss, none of this is abstract. A particle is not a carbon unit. It is a possible meal. A thin rain from above is not a cycle. It is the difference between emptiness and nourishment. A deep-sea sponge filtering water does not know that sunlight began the chain. A sea cucumber crossing the sediment does not know that it is part of a planetary exchange. A small crustacean picking through detritus does not know that human scientists will later describe flux sequestration or carbon transport. It knows only the food that has arrived. There is something humbling in that. The great systems of Earth are not always grand in appearance. Sometimes they are made of small bodies, eating smaller pieces of waste, sinking through darkness of microbes, altering what larger animals leave behind. Sometimes the planet works through what seems almost invisible. The deep ocean's hunger is not loud. It is continuous. Marine snow falls through regions where animals wait in the water column, and then through deeper spaces where life becomes more widely scattered. It settles on rocks, mud plains, slopes, canyons, and the strange landscapes of the seafloor. It gathers in hollows and is swept along by currents. It becomes part of sediment, part of bodies, part of microbial work. In some places, currents carry more food. In others, the deep seafloor may be extremely poor, receiving only a sparse rain from above. This unevenness matters. The deep ocean is not one uniform desert. It has patches, pathways, richer zones, leaner zones, and local histories written by what arrives. A canyon may channel particles downward. A seamount may alter currents and gather life around it. A place beneath productive surface waters may receive more organic matter than a quieter region of the open ocean. Even in darkness, geography matters. Still, much of the abyss lives with scarcity. Scarcity shapes bodies. It shapes behavior. It favors patience, efficiency, and the ability to use what little comes. Some animals grow slowly, Some reproduce slowly. Some conserve energy in ways that would seem strange to surface creatures living in a richer, brighter world. The deep does not hurry because hurry is expensive. And in that slowness, the falling snow becomes one of the most important images in the sea. It is not sacred in a human religious sense, but everything depends on it. The smallest particle can enter a chain of survival. The faintest rain can sustain a hidden community. The remains of the surface world can become the breath of the abyss. The deep ocean waits beneath every day. When the sun rises above the surface, plankton grow. When night falls, animals rise to feed. When bodies release waste or die, fragments begin to sink. Whether humans are watching or not, the ocean keeps passing life downward through layer after layer of water until the darkness receives it. This receiving is not passive. The deep sea takes what falls and transforms it. It breaks it apart, feeds on it, buries it, circulates it, and makes it part of other lives. The abyss is not a grave at the bottom of the world. It is a place where endings are slowly processed into continuance. That is why marine snow belongs at the center of this journey. It lets us see the deep ocean not as emptiness, but as a vast, patient hunger. It lets us understand that the darkness below is linked to the brightness above by a rain too quiet for most of us to imagine. But the rain is not always gentle. Most of the time, the deep ocean receives life in fragments, flakes, particles, shells, waste bodies, small enough to vanish into the sediment. Yet sometimes something far larger begins to fall. Not a particle, not a flake, not the remains of a plankton bloom. A whole body descends. Somewhere in the open ocean, a whale dies. Its enormous body, once held near the surface by breath motion and buoyancy, begins to sink. Slowly at first, then steadily, it leaves the light behind and enters the dark water below. For the deep sea, this is not snow. It is a world arriving from above. Somewhere far above the abyss in water, still touched by light, a whale takes its final breath. It may happen quietly, far from land, beyond the sight of any ship. A body that once rose and sank with the rhythm of breathing begins to drift. For years, perhaps decades, it crossed enormous distances through the ocean, carrying warmth, muscle, blood, fat, memory, and motion. It fed in one place, traveled to another, sounded into deep water, returned to the surface, and filled its lungs again. Then life leaves it. For a time, the body may float. Gases gather inside it. Birds may come. Sharks may feed. Waves may turn it slowly under the open sky. But eventually what remains begins to sink, leaving the bright water behind and entering the long blue descent. This is one of the deep ocean's rarest arrivals. Most food reaches the abyss as fragments, small particles, drifting flakes, some fecal pellets, dead plankton, tiny remains falling one by one through darkness. Marine snow feeds the deep in a slow, patient way. A whale fall is different. It is not a faint rain. It is a whole world of flesh, bone, fat, and stored energy arriving at once. As the whale sinks, it passes through the same layers we have already entered. It descends through the upper ocean, where sunlight still has power, then through the twilight zone, where migrating animals rise and fall. Smaller creatures may gather along the way. Some bite, some trail the falling body, some vanish into the dark after taking what they can. But the whale continues downward. The pressure increases. The light fades. The body moves out of the realm where ordinary human sight would follow it. It may sink for hours, depending on depth currents, gases, and the condition of the carcass. Slowly, the enormous shape enters water where no daylight remains. Then at last, it reaches the seafloor. In that first moment, the whale body lies on mud rock or sediment, like something misplaced from another world. It was born to move through open water. Now it rests in darkness, far below the waves, where food usually arrives in tiny pieces. Around it, the deep sea floor may have been quiet for a long time, receiving only the slow fall from above. But the arrival of a whale changes everything. The first visitors may come quickly drawn by scent spreading through the water. In the deep ocean, smell and chemical traces can matter enormously. A carcass is not silent to the animals around it. It releases information. It announces abundance in a place where abundance is rare. Scavengers gather. Hagfish may arrive, their long bodies twisting into openings in soft tissue. Deep-sea sharks may tear at the flesh. Crabs, amphipods, and other scavengers move across the body, cutting, scraping, and feeding. What was once a single animal becomes a feeding ground for many. There is little waste in this scene. To human eyes, a carcass can feel like an ending. In the deep sea, it begins a sequence. The body is not simply consumed and gone. It changes through stages, and each stage invites a different community. At first, the large scavengers take the soft tissue. Flesh that once powered long migrations now feeds animals that may have waited in lean darkness for an event like this. Fat becomes energy. Muscle becomes movement in other bodies. The whale's stored life spreads outward, bite by bite, into the deep. This stage can be surprisingly intense compared with the usual quiet of the abyss. Animals crowd the carcass. Some feed directly. Others search the sediment nearby for scraps. Pieces are torn loose and carried away. Smaller creatures find shelter in folds, wounds, and spaces opened by larger mouths. The whale becomes a landscape. A jawbone is no longer just bone. It is an edge, a surface, a place for microbes, worms, and small animals to gather. A rib becomes structure. The hollow places in the skeleton become passages. The sediment beneath the body becomes enriched by what seeps downward. In the deep ocean, where hard surfaces may be limited across wide, muddy plains, even the bones can matter physically. They give animals something to attach to, move across, or live near. They interrupt the flatness of the sea floor. They make a small geography where there was once only open sediment. As the soft tissue disappears, the scene changes. The first feast gives way to a slower afterlife. Smaller animals continue to work over the remains. Crustaceans pick through scraps. Worms and microbes enter the story more deeply. The sediment around the whale grows richer with organic matter. What the scavengers do not consume directly becomes food for other lives in other forms. The body spreads into the ground. This second stage is quieter, but it may last longer. The whale is no longer a single banquet for large mouths. It becomes a source of enrichment. The mud around it changes chemically and biologically. Animals that feed on organic rich sediment may gather. Microbes multiply. The border between carcass and seafloor begins to blur. A whale fall does not feed only those that arrive first. It feeds layers of life, some visible, some microscopic, some slow enough to be missed, if we only look for drama. Then comes the skeleton. Whale bones are rich in lipids, especially in large whales. Even after the flesh has been stripped away, the bones can hold energy. In deep darkness, where food is often scarce, this matters. The skeleton may continue to support life long after the body has lost its familiar shape. This is where some of the strangest whale fall life appears. Bone-eating worms, often known by the genus Oases, can grow on whale bones. They do not have mouths in the ordinary sense. Instead, they use root-like structures to penetrate bone and rely on symbiotic bacteria to help them access nutrients. Their presence turns the skeleton itself into a feeding ground. The image is quiet and strange, small, red-tipped worms growing from bone in the dark, drawing life from what remains of a giant. Again, the deep ocean asks us not to rush the meaning of death. The whale's body has not simply ended. It has become a process unfolding through scavengers' sediment, bacteria, worms, and chemistry. It has become time. In later stages, chemical processes around the bones can support communities that resemble, in some ways, other chemically enriched places on the seafloor. As organic compounds in the bones break down, they can help fuel microbial activity. Those microbes may support other organisms, extending the whale's afterlife even further. A single fall can last for years. In some cases, parts of the whale fall community may persist for decades, especially where bones remain and chemical energy continues to be available. The exact duration depends on the size of the whale, the depth oxygen levels, current scavenger activity, and many other conditions. The deep sea is never one simple place. Each fall becomes its own small history. This is one of the most beautiful and humbling ideas in deep ocean ecology. A death at the surface can become a long event in the dark. A whale lives in motion, crossing distances too large for most humans to imagine. It feeds, breathes, communicates, and carries its body through the sea. Then after death, that same body continues to move through the ocean's systems. It sinks, it feeds, it shelters, it changes chemistry, it becomes habitat, it becomes a gathering place for lives that may never have encountered such abundance otherwise. The whale is gone, but the whale fall remains. For the animals of the abyss, this arrival may be transformative. Imagine a seafloor that has known only a sparse rain of particles for months or years. Then an enormous source of food lands in the darkness. Chemical traces spread. Scavengers arrive from distances we are still learning to understand. The quiet plain becomes active, crowded, and layered with opportunity. The deep ocean does not waste the dead. This does not mean the scene is gentle. It is feeding. It is tearing, dissolving, burrowing, digesting, competing, and being eaten in turn. But it is not meaningless. Every part of the body enters another relationship. The whale's death becomes an event shared among species, microbes, sediments, and time. There is a kind of dark generosity in it, not generosity in the conscious sense. The whale does not choose to give itself to the abyss. The scavengers do not gather in gratitude. Nature does not arrange the scene for symbolism. But from the outside, we can see the transformation clearly. What was once one life becomes many smaller continuations. In a sleep documentary, this is not a scene to hurry past. The whale fall is one of the deep sea's slow stories, and it reminds us that the ocean often works beyond the scale of human attention. A body may disappear from the surface, and for the world above the story seems over. But below, the longer chapter has just begun. The deep ocean is full of these hidden continuations. A particle falls and feeds a small mouth. A fish dies and becomes food for scavengers. A squid is eaten and its energy moves into another body. A whale descends and the abyss gathers around it like night gathering around a flame. But unlike a flame, this energy does not burn quickly. It is consumed in stages. It is held, released, buried, transformed, and shared among communities that may change slowly over years. The whale fall becomes a clock on the seafloor, marking time through disappearance. First, the body is recognizable, then it is opened, then it is reduced, then it is bone. Then even the bone becomes a place of feeding. At each stage, different lives arrive, stay, leave, or vanish. The community is not fixed. It succeeds itself, almost like a forest after a fallen tree, but in cold darkness and under immense pressure. This comparison is imperfect, but useful. In a forest, A fallen tree becomes home to fungi, insects, mosses, beetles, birds, and new seedlings. It changes the light, the soil, and the small lives around it. In the deep ocean, a fallen whale does something similar, though in a world without trees, sunlight, or air. It creates structure, food, and chemistry where there may have been very little before. It is a fallen giant in a world of scarcity. Whale falls also raise a larger question about deep-sea connection. For a long time, scientists wondered how certain deep-sea organisms might spread across vast areas of seafloor, especially when suitable habitats are scattered. Whale falls may act as stepping stones for some kinds of life, linking ecosystems across distance. The idea is still part of scientific discussion, and not every detail is settled, but the possibility adds another layer to the story. A dead whale may not only feed a place, it may help connect places. This is the deep ocean, again refusing to be simple. What looks like a single event may belong to a larger network. A carcass on the seafloor may relate to animals that live near vents, seeps, sediments, and other chemically rich environments. It may reveal how life travels, persists, and adapts across the largest habitat on Earth. Yet for all the science, the image remains very simple. A whale falls, darkness receives it, life gathers. That simplicity is powerful because it reverses our sense of scale. At the surface, a whale is already enormous. It can dwarf boats, breach through waves, and fill the human imagination with size and breadth. But when it enters the deep sea, its size takes on another meaning. It becomes not just a large animal, but a sudden concentration of energy in a world where energy often arrives as dust. The abyss, which may seem empty, is revealed as ready, ready to detect, ready to feed, ready to transform, ready to turn one body into many processes. This readiness is part of what makes the deep ocean feel alive, even when it appears still. Its animals may be scattered, its movements may be slow, its darkness may hide almost everything from us. But when food arrives, the response can be swift, complex, and deeply organized by need. The whale fall shows that the deep sea is not asleep, it is waiting. And waiting in the deep ocean is not inactivity. It is a form of survival. It is how life persists between rare events. It is how animals endure scarcity until scent current or chance brings them toward food. It is how the abyss remains quiet for long stretches, then suddenly becomes a center of motion. After years, the whale may become difficult to recognize. The shape that once moved through surface water is gone. The flesh has vanished into other bodies. The bones are bored, softened, colonized, or scattered. The sediment keeps traces of what happened. The community moves on or changes into something else. The ocean closes over the event, but not completely. Nothing in the deep sea disappears in the simple way we imagine. It is broken down, transformed, carried, buried, eaten, or dissolved into other cycles. The whale becomes part of the dark, not by vanishing from meaning, but by entering too many meanings to follow. In that sense, a whale fall is one of the clearest windows into the deep ocean's hidden work. It shows us feeding decay community chemistry, patience, and renewal in one place. It makes visible for a while the quiet law that has been operating all along. What falls into the deep does not merely end there. It becomes available to darkness. But the whale fall also prepares us for an even stranger discovery. So far, much of the deep ocean's nourishment has come from above. Marine snow falls from the sunlit surface. Whale bodies descend from the breathing world. Even in darkness, the chain still begins in some way with light. Yet there are places on the seafloor where life does not wait for a body to fall. There are places where the ocean floor itself opens, where hot mineral-rich water rises from beneath the crust, where chemicals pour into black water, and where living communities gather around energy from the earth rather than sunlight from the sky. The whale fall teaches us that death can become a world. Next, the deep ocean will show us that darkness can also bloom around the heat of the planet itself. 6. The black. For much of our journey, the deep ocean has been waiting for gifts from above. Marine snow falls from the sunlit water. A whale body descends from the breathing world. Even in darkness, much of the abyss remains tied to the surface, fed by sunlight after it has passed through plankton, fish waste death, and sinking matter. But the deep ocean does not receive all of its life from above. There are places far below the waves where the seafloor itself seems to breathe. Black water rises from cracks in the earth. Heat pours into cold darkness. Minerals cloud the water like smoke. Around these strange openings, life gathers in numbers that seem almost impossible for the deep sea. These are hydrothermal vents. They are not gentle springs. They are openings in the seafloor where seawater has seeped down through cracks, been heated by the Earth's interior, reacted with rocks, and returned upward, carrying dissolved minerals and chemicals. When that hot fluid meets the near-freezing water of the deep ocean, minerals can precipitate out, forming dark plumes that look like smoke rising into the Black Sea. Some vents are called black smokers because of this appearance. The name sounds almost industrial, as if a chimney from a hidden factory has been placed at the bottom of the ocean. And in a way, the image is fitting. These places look like chimneys towers and broken spires built by minerals rather than hands. They stand in darkness, surrounded by pressure cold and silence pouring out heat from the planet below. For a long time, humans did not know such places existed. The deep sea floor was often imagined as cold, dark, and mostly barren, a vast plain, receiving only the slow remains of life from above. Scientists knew that some animals lived there, and that the abyss was not empty, but the idea of dense communities thriving around volcanic heat in total darkness was not part of the old picture. Then in 1977, scientists exploring the Galapagos Rift found something that changed the way people understood life on Earth. They descended into deep water expecting geology. What they found was biology. Around the vents were animals living in abundance, giant tube worms, clams, mussels, crabs, and other creatures gathered around warm, chemically rich water. There was no sunlight, no green plants, no photosynthesis in the ordinary surface sense. And yet life was not merely present, it was flourishing. The discovery felt like a quiet revolution. Until then, much of biology had been built around the idea that sunlight was the beginning of nearly every food web. Plants and algae captured sunlight, animals ate plants or each other, and energy moved through life from that bright beginning. But here was a community at the bottom of the ocean, in darkness, built on a different foundation. Not sunlight, chemistry. At the heart of these vent ecosystems are microbes. Some bacteria and archaea can use chemical energy from compounds such as hydrogen sulfide or methane to build organic matter. This process is called chemosynthesis. It is not a replacement for photosynthesis everywhere, but in these dark places, it becomes the foundation of a whole community. The word may sound technical, but the idea is simple enough to feel. At the surface, life often begins with light. At the vent, life begins with chemicals rising from stone. The animals around hydrothermal vents depend on this microbial work. Some graze on microbial mats. Some filter bacteria from the water. Some carry symbiotic microbes inside their own bodies. The giant tube worms are among the most striking examples. They have no mouth or digestive system in the ordinary sense. Instead, they house bacteria inside them, and those bacteria use chemicals from vent fluids to make food. The tube worm becomes the living partnership. Its red plume reaches into the water, helping gather what the bacteria need. Inside, Invisible microbes do the work that sunlight cannot do in that place. Together, they turn chemical energy into living tissue, allowing enormous worms to grow in a world where no plant could survive. This is one of the deep ocean's great lessons. Life does not always look for the same door. Where sunlight cannot enter, chemistry may open another path. Where food does not fall often enough, Earth itself may provide energy. Where the seafloor appears hostile, life may gather around the very forces that make it strange. A hydrothermal vent is an oasis, but not in the soft green sense of a desert spring. It is hot, mineral-rich, unstable, and often toxic to many forms of life. The fluids can be extremely hot, though they cool rapidly in the surrounding seawater. The chemicals that sustain some organisms would poison others. The environment can change quickly, and vents may eventually slow shift or die. And yet around them, life crowds close. Tube worms may cluster in dense groups. Mussels and clams may attach near flowing water. Crabs and shrimp may move among the structures. Microbes coat surfaces in pale or colored films. Predators and scavengers enter the community, feeding on animals that feed directly or indirectly on the chemical energy rising from below. The vent field becomes a city of necessity. Every position matters. Too far from the vent, and the chemicals may be too weak. Too close, and the heat or chemistry may be dangerous. Animals live along gradients of warmth, toxicity, oxygen, and food. The community is built not around comfort, but around balance. In the deep ocean, comfort is rarely the point. Survival is. These black oases can feel almost alien because they break so many surface expectations. On land, we look for life where there is light, fresh water, soil, warmth, and air. At vents, there is darkness, salt water, crushing pressure, strange chemistry, and heat rising from rock. Yet life does not treat this as impossible. It treats it as a set of conditions to be solved. The result is not a world outside nature. It is nature revealing a wider range than human imagination first allowed. Hydrothermal vents also remind us that the seafloor is not simply a floor. It is part of a living planet. Beneath the ocean, Earth's crust cracks, shifts, cools, and releases heat. Seawater moves into rock and returns changed. Minerals build chimneys. Chemicals feed microbes. Microbes feed animals. Geology becomes biology. The boundary between Earth and life begins to blur. This is one reason vents hold such fascination for scientists. They are not only habitats, they are meeting places between the planet's interior and the living world. They show how energy can move from rock into organisms, from deep heat into flesh, from chemistry into communities. They also invite larger questions about where life might begin and where else it might survive. Some scientists have considered whether early life on Earth could have been connected to environments like hydrothermal systems. Others look at vent communities and wonder about icy moons in the outer solar system, where dark oceans may exist beneath frozen crusts and chemical energy may be present without sunlight. These questions are still scientific questions, not certainties. But the vents make them imaginable in a new way. They show that darkness alone is not enough to prevent life. Still, it is important not to turn hydrothermal vents into a fantasy world. They are real places with real limits. They do not fill the whole deep sea. They occur where geology allows them. Their communities depend on local chemistry flow and stability. They can be separated from one another by vast distances of ordinary deep-sea floor. A vent is not the entire abyss. It is a window. Through that window, we see that the deep ocean has more than one kind of economy. There is the slow rain from above. There are sudden falls of bodies, And there are places where energy rises from below, where life gathers not around a dead whale or a drifting particle, but around the restless interior of Earth. Cold seeps offer another version of this hidden world. Unlike hydrothermal vents, cold seeps do not release extremely hot fluids in the same dramatic way. Instead, methane, hydrogen sulfide, and other chemicals seep slowly from the sea floor. The water may not look as violent or smoky as a black smoker, but the principle can be similar. Microbes use chemical energy, and larger communities build around them. At cold seeps, clams, mussels, tube worms, bacterial mats, and other organisms may gather in dark water. The scene may look quieter than a vent field, but it is still extraordinary. Life is collecting around invisible chemical flow, around something rising through mud and rock from below. Again, the deep sea refuses the idea of emptiness. A plain that looks barren may hide chemical seepage. A patch of seafloor may support life because methane rises there. A field of clams or worms may mark a place where the earth is releasing energy slowly enough for organisms to build a community around it. The deep ocean is full of such hidden conditions. To see it only as dark water is to miss the local histories written into the sea floor. Every vent field, every seep, every whale fall, every canyon, every current-swept ridge has its own story of arrival, chemistry, food, and time. The abyss is not one uniform darkness. It is a vast patchwork of waiting, feeding, falling, rising, dissolving, and gathering. Hydrothermal vents make this patchwork visible in one of its most dramatic forms. In the glow of a submersible's lights, a vent community can look startlingly alive. White tube worms stand in clusters. Crabs move slowly over mineral surfaces. Plumes of dark fluid rise and curl into the surrounding water. The scene seems both ancient and temporary, as if it belongs to the beginning of the world and could vanish without warning. This is another tension of vent life. The energy is powerful, but the habitat may not last forever. A vent can change as fluid flow shifts. Chimneys can collapse. New vents can open elsewhere. Communities must colonize, persist, and sometimes disappear. Life at the vents is not stable in the way a forest can seem stable. It lives close to change. And yet that instability may also create opportunity. When a new vent opens, microbial life can begin to grow. Animals may arrive over time, carried as larvae through the deep ocean. A community forms where there was once only rock and fluid. The ocean floor becomes animated by heat and chemistry, then perhaps many years later, quiet again. In this sense, vents are not just places, they are events. They begin. They change, they build, they fail. They are born from geological motion and inhabited by organisms adapted to conditions most surface life could never endure. For a listener drifting through this dark ocean, the vents may feel like the deepest answer to the question we have been following. What happens below while the world sleeps? Here below sleep, below sunlight, below ordinary night, the earth itself is feeding life, not loudly, not visibly from above, but continuously wherever the conditions are. Right, the surface world could go quiet for 1,000 nights, and the vent communities would continue in their own terms. Bacteria would work in darkness. Tube worms would hold their red plumes in the flow. Mussels and clams would cluster near chemical sources. Crabs would move through mineral towers. Hot fluid would rise and vanish into cold water. No sunrise would announce the beginning of their day. No sunset would close it. Their rhythm belongs to chemistry flow pressure and the deep movements of the planet. This is where the meaning of night changes completely. At the surface, night is the absence of the sun for a few hours. In the twilight zone, it is a signal to rise. In the abyss, darkness is the permanent background. At the vents and seeps, darkness is not a problem to be solved by waiting for dawn. It is simply the condition in which life has learned another way to begin. The discovery of these ecosystems did not make the deep ocean less mysterious. It made it more mysterious, but in a better way. Before, the darkness might have seemed like emptiness. Afterward, it became possibility. If life could gather here around heat and chemicals at the bottom of the sea, then the living world was wider, stranger, and more inventive than we had imagined. The deep ocean was not just receiving the remains of life, it was making life from the planet's hidden energy. And still, even around these black oases, much remains difficult to know. Human visits are brief. Machines descend for hours, not lifetimes. Lights reveal one angle and hide others. Samples come up changed by pressure and temperature. A community that appears still on camera may be full of chemical exchange, microbial work, and slow animal movement that our senses can barely follow. The deeper we go, the more we depend on instruments. We need submersibles to see. We need sensors to measure heat and chemistry. We need sampling arms to gather rocks, fluids, and organisms. And increasingly, we need to listen, because the ocean's darkness is not only a visual challenge, it is also a place where sound carries meaning across distance. After the vents, the deep ocean feels less like a silent void and more like a hidden interior of the planet, alive with forces we only partly understand. Heat rises, chemicals flow, communities gather, particles fall from above, animals move through black water, and somewhere beyond the range of our lights, other forms of activity continue without waiting to be seen. The eye has taken us far, but not far enough. In darkness, sight has limits. A camera can show what passes in front of it. A submersible can illuminate a small patch of seafloor. A vehicle can reveal a vent, a whale fall, a drifting animal, or a glowing body for a moment. But the ocean is larger than any beam of light. To understand more of it, we must turn to another sense, one that travels farther in water than sight, one that can cross darkness, bend through distance, and carry the presence of animals, waves, ships, ice, earthquakes, and whales through the sea. The deep ocean is not only glowing, feeding, falling, and rising, it is listening. After the black oases of the seafloor, the deep ocean feels less empty than before. We have seen life gather around falling bodies, around drifting particles, around heat and chemistry rising from the earth. We have watched darkness glow, feed, wait, and transform. But even after all of that, the ocean remains too large for sight alone. A light can only reach so far underwater. A camera can show only the small patch of darkness in front of it. A submersible may descend for hours and reveal wonders, but beyond its beam, the black water continues in every direction. The ocean does not end where our vision ends. So, to understand the deep, we must listen. Sound behaves differently in water than it does in air. It travels farther, often much farther, and in the deep ocean, it can cross distances that light could never cross. Where sight fails, quickly sound can keep moving. It can bend, carry, echo, fade, and return. For many ocean animals, this matters more than brightness. In darkness, sound becomes a way of knowing. It can reveal distance, movement, danger, identity, territory, and presence. A creature may not see another body in the black water, but it may sense vibration, pressure, or low-frequency sound moving through the sea. The deep ocean is not silent. It only seems silent to us because we live above it, separated by the surface. Stand on a beach at night, and you hear waves, wind, perhaps the distant engine of a boat. The true soundscape below remains hidden. The water carries a world of calls, pulses, clicks, groans, crackles, movement, and far-off disturbances that the human ear cannot simply enter without help. To listen beneath the waves, humans use instruments. Hydrophones are underwater microphones, lowered into the sea, mounted on moorings attached to vehicles or placed in long-term listening stations. They allow scientists to hear what darkness hides. Through them, the ocean becomes not only a place to look into, but a place to receive. And what arrives is not one sound, but layers. There are sounds made by animals. Whale calls can travel for great distances, especially low-frequency calls that move through water with astonishing reach. Some whales communicate across wide ocean spaces, sending voices through a world where visual contact would be impossible. Their calls do not simply fill silence. They map presence through distance. There are fish that produce sounds, too. Some make pulses, knocks, hums, or drumming noises by vibrating muscles or structures inside their bodies. These sounds may help with mating territory schooling or other behaviors. Not every fish is silent, and not every underwater sound belongs to whales. There are also the sounds of the planet itself. Earthquakes rumble through the ocean. Undersea volcanoes crack, shift, and release energy. Ice can creak and fracture in polar seas. Waves above produce continuous background sound. Rain striking the surface creates a texture that can be heard below. Even the motion of sediment current and bubbles can become part of the ocean's acoustic world. To the human imagination, darkness is often linked with quiet, but in the ocean, darkness and sound belong together. The farther down we move, the more important this becomes. In deep water, where sunlight never arrives, a sound may be the first sign that something exists beyond the reach of vision. It may pass through a region long before any body comes into view. It may reveal scale before shape. A whale somewhere in the dark may call, and the sound travels outward through layers of pressure and cold. It moves through water that no eye can fully search. It crosses paths with currents, seamounts, and unseen animals. It becomes part of a living acoustic landscape, older than ships, older than engines, older than any human attempt to record it. There is a gentleness in imagining this. A whale does not need the ocean to be bright in order to be present. Its body may be hidden, its path unseen, its depth unknown. But its voice can move through darkness like a long thread connecting one hidden body to another. In some parts of the ocean, sound can travel especially far because of the way temperature, pressure, and salinity shape the speed of sound in water. Scientists speak of sound channels layers, where sound may be guided across great distances. The idea is almost dreamlike, an invisible corridor inside the sea, not for bodies, but for vibrations. The ocean has roads made of sound. These roads are not fixed like roads on land. They depend on conditions in the water. But they remind us that the sea has structures we cannot see from above. It has layers of temperature, pressure, chemistry, motion, and sound. To live there is to live inside a world of gradients. For animals, sound may be part of finding the way. It may help them detect environments, locate others, avoid danger, or recognize familiar patterns. The ocean is not a blank volume. It is filled with cues, and sound is one of the most far-reaching. For humans, listening has become a way to study what cameras cannot continuously see. A hydrophone can remain in the water through long nights, storms, seasons, and migrations. It can record when no ship is present and no light is shining. It can reveal whale movements, fish choruses, seismic activity, ice noise, and human disturbance. It allows the deep ocean to speak in time. This matters because the deep sea does not easily give itself to brief visits. A submersible might pass a place once and see little, while a listening instrument may detect patterns over months. A creature that never appears on camera may still leave a voice. A migration that happens in darkness may still alter the soundscape. Listening turns absence into evidence. But sound can also remind us how easily we misunderstand the ocean. When humans first look into deep water, we may think mostly of shape, strange fish, glowing bodies, vent chimneys, whale bones. When we listen, the ocean becomes less like a scene and more like an atmosphere. It is not only something to observe, it is something happening around us. This shift changes the mood of the journey. The deep ocean is not merely a dark room with hidden objects inside it. It is an active medium carrying messages, movements, and disturbances. A sound made in one place can travel into another. A call can cross a region where the caller will never be seen. A vibration can arrive before its source is known. In the darkness, sound gives distance a body. Some sounds are natural and ancient. Others are new. Ships now cross the ocean day and night, their engines and propellers sending low-frequency noise into the water. Industrial activity, sonar, drilling construction, and other human uses of the sea add to the soundscape. Even when the surface seems peaceful to us, the water below may carry the ongoing noise of human movement. This does not mean every sound is equally harmful, or that the ocean has become one single field of disturbance. The reality is more complicated, varying by place, depth, frequency, species, and exposure. But the central point is simple enough. Humans have added voices to a world where sound already mattered. For animals that depend on sound, this can change the conditions of life. A whale call may have to travel through background noise. A fish chorus may overlap with engines. A listening animal may detect human-made vibration where once there was mostly wave, rain, ice, and biological sound. The dark ocean is not untouched by the world above. Our presence enters it not only as plastic heat or fishing lines, but as noise. This is a quiet modern tension, and it should be handled quietly. The deep ocean is not a victim in a simple story. It is vast, dynamic, and powerful. But it is not beyond influence. A world we barely see can still be altered by what we do. A darkness we once imagined as remote may already be carrying the sound of our machines. The thought is sobering. While people sleep in coastal cities, vessels continue crossing black water. Their sound may travel downward and outward. Somewhere below, a whale may call. Somewhere else, fish may gather and produce their own signals. A hydrophone may record, both not as separate stories, but as one mixed soundscape. The ocean listens to everything placed into it. Of course, the ocean does not listen in the human sense. It has no single ear, no central mind, receiving every vibration. But countless animals are sensitive to sound and movement. The water itself carries pressure changes. Instruments translate those changes for us. In that sense, the ocean becomes a vast listening space, not because it thinks, but because sound can move through it with such consequence. To listen to the deep is also to accept uncertainty. A recording may capture a sound whose source is not immediately known. It may be biological, geological, mechanical, or something altered by distance. Scientists compare patterns, frequencies, timing, and location. They match sounds to known animals when they can. They leave some sounds unresolved when they must. This uncertainty can be frustrating, but it is also honest. The ocean does not become simple just because we record it. Listening opens new questions. What animal made that call? How far did it travel? Was it part of mating, feeding navigation distress, or something else? Did the sound mean one thing nearby and another thing at a distance? Did human noise mask it, distort it, or pass without consequence? Every answer brings another layer. In this way, underwater sound is like bioluminescence. It is a language we can detect before we fully understand. We know that signals exist. We can record them, map them, sometimes identify them. But many meanings remain inside the lives of the animals themselves. A whale call is not only a waveform. A fish sound is not only a frequency. A crack in polar ice is not only a pressure event. Each belongs to a world of conditions, histories, bodies, and responses that we are still learning to hear. The deep ocean teaches humility through listening. A camera gives the comfort of an image. We can point to a fish, a worm, a vent, a bone, and say, there it is. Sound gives a different kind of knowledge. It may arrive without shape. It may suggest presence without showing a body. It may prove that something happened without letting us fully see it. That kind of knowledge is quieter but powerful. Imagine a hydrophone suspended in black water through the night. Around it no light reaches. Particles drift past. Animals pass unseen. A distant whale call enters the recording long and low. Later, a faint mechanical hum appears, then fades. A crack from the earth or ice moves through the background. Rain far above stipples the surface and the sound filters downward. The instrument does not sleep. It waits, receives, and remembers. In that waiting, it becomes almost like the deep sea itself. Patient, unblinking, open to events that may be separated by minutes, days, or seasons. The ocean's soundscape is not a performance. It is a record of life and motion continuing whether or not anyone is present to hear it. This brings us back to the human world above. At night, a person may lie in bed near the coast and hear the faint rhythm of waves. The sound may feel simple, soothing, repetitive. It may help the mind release the day. But beyond that surface rhythm, below the dark water, the ocean is carrying a far larger music. Not music in the human sense, a layered presence. Whales calling through distance. Fish producing faint choruses. Currents moving around seafloor ridges. Rain touching the surface. Ice shifting. Earth trembling. Machines crossing. Deep animals sensing vibrations too subtle for us to imagine. The ocean's darkness is alive with things that do not need light to be real. And this is why listening matters. We began with what the eye could notice. The quiet surface, the rising migration, the flicker of living light. We moved into what the body of the ocean receives: snow, carcasses, heat, chemistry. Now we have entered what the ocean carries beyond sight. Sound reveals continuity. It shows that the deep sea is not a set of isolated scenes. It is connected by movement through water, by signals crossing distances, by human noise entering habitats, by instruments listening where people cannot remain. It shows that darkness has its own forms of awareness, even when those forms are not ours. Still listening also reveals how little we know. A sound may travel farther than a camera can see, but it does not explain everything. A hydrophone can hear a whale without showing what the whale sees, feels, or follows. It can record a ship without measuring every effect on every animal. It can capture mystery without solving it. The deeper we listen, the more the ocean becomes both more present and more hidden. This is the final threshold before our journey widens. We have followed darkness from the surface into migration, from migration into light, from light into falling food, from falling food into whale falls, from whale falls into vents, and from vents into sound. Each layer has shown us that the deep ocean is active in ways human life rarely notices. But now another question waits. How much of this world have we actually seen? How much of it have we only inferred through instruments, fragments, samples, and brief descents? And what does it mean to live on a planet whose largest habitat continues its hidden work below us, whether or not we understand it? The hydrophone keeps listening in the dark. Beyond its reach, the ocean continues. Beyond the listening instruments, beyond the beams of submersibles, beyond the small circles of light that humans lower into the sea, the deep ocean continues. It does not wait for us to name it. It does not pause when a vehicle returns to the surface. It does not become still when a ship leaves the research site or when the last recorded sound is filed away in a laboratory. Long after the instruments are retrieved, particles continue to fall, animals continue to rise and sink, vents continue to breathe, and voices continue moving through the dark. This is the final truth. Our journey has been circling from the beginning. The deep ocean is not a distant emptiness beneath the world. It is part of the world's hidden life. For most of human history, the deep sea existed more as imagination than knowledge. People knew the ocean's surface. They knew tides, storms, fish reefs, currents, coastlines, and the danger of water that could swallow ships. But the deeper layers remained beyond ordinary reach. The human body could not descend there. Human eyes could not see there. Human lungs, bones, and senses belong to air and sunlight. So, the deep ocean became a place of rumor, fear, wonder, and absence. Only slowly did tools begin to change that. Sounding lines measured depth. Dredges brought up strange fragments from the sea floor. Later, submersibles carried people into darkness. Cameras revealed animals that looked almost impossible from the surface. Remotely operated vehicles extended human reach without requiring a human body to endure the pressure. Autonomous vehicles began tracing routes through water where no person could remain. Each tool opened a window, but a window is not the same as a world. A camera may show a single animal drifting in black water, but not the whole life of that species. A sample may bring up a creature, but pressure and temperature change what reaches the deck. A map may reveal mountains, trenches, ridges, plains, and canyons on the sea floor, but a map cannot tell us all the relationships living there. It can show shape. It cannot fully show the slow activity of a hidden ecosystem. Even now, much of the deep ocean remains unseen in any direct way. This does not mean it is unknowable. It means our knowledge is partial, built through glimpses, measurements, traces, recordings, and careful inference. Scientists piece together the deep from many kinds of evidence: acoustic data, chemical readings, sediment cores, genetic samples, camera footage, animal tags, drifting instruments, and long-term observatories placed where humans cannot stay. The deep ocean teaches us to know without possessing. It asks for patience. It asks for humility. It asks us to admit that a world can be real, active, and important, even when it resists easy observation. In an age when so much of the planet can be photographed, mapped, streamed, and measured instantly, the deep sea remains a reminder that Earth still has rooms we enter only briefly. And yet those rooms are not separate from us. The deep ocean helps move carbon through the planet. It receives the remains of life from above. It stores some of what sinks, transforms some of what arrives, and returns some of it through currents and cycles. We are still working to understand. It is part of the long exchange between atmosphere, surface water, living bodies, sediments, and time. The carbon story is difficult because it is not a simple straight line. A particle that sinks may be eaten before it reaches depth. A migrating animal may feed near the surface and release carbon lower down. A dead body may carry energy into the dark. Some carbon remains in deeper water for long periods. Some returns sooner. Some becomes part of sediments. The details depend on depth, temperature, currents, microbes, oxygen species, and chance. This uncertainty matters. It would be easier to describe the deep ocean as a perfect storage place, a silent vault beneath the waves. But the living ocean is not a vault. It is a moving system. It breathes, chemically circulates, physically feeds biologically, and changes through time. Its power comes from interconnection, not simplicity. While people sleep, this interconnection continues. In the upper layers, plankton and small animals respond to darkness. In the twilight zone, migration carries energy through depth. In the mid-water, lights flash briefly and vanish. In the abyss, marine snow falls in pale fragments. On the seafloor, scavengers search microbes work, and slow animals cross the sediment. At vents and seeps, chemistry feeds communities that do not wait for dawn. Through all of it, sound travels. The world above may measure night in hours. The deep ocean measures it differently. Some of its rhythms are daily, tied to sunset and dawn. Others are seasonal, tied to blooms and shifting surface waters. Others last years as whale bones are consumed and vent communities grow. Others belong to geological time, to crust opening heat, rising ridges spreading, and sediments gathering grain by grain. In the deep sea, many clocks run at once. That is one reason it feels so difficult to understand. The deep ocean is not only far away, it is slow and sudden at the same time. A particle may take a long time to fall. A predator may strike in an instant. A whale fall may feed life for years. A vent may build a tower slowly, then collapse. A sound may cross great distance faster than any body could travel. A species may live in patterns we have only recorded for a few minutes. Our attention is brief, the ocean's processes are not. This difference creates a quiet tension between human curiosity and deep time. We want answers that fit inside. Expeditions, papers, documentaries, maps, and images. The ocean offers fragments. It lets us see enough to be astonished, but not enough to be finished. Perhaps that is why the deep sea remains so powerful in the imagination. It is not merely strange, it is unfinished in our understanding. But unfinished knowledge brings responsibility. The deep ocean is no longer beyond human influence. Even in places where no person has descended, the signs of surface civilization can arrive. Plastic debris can sink. Chemical pollutants can move through food webs. Fishing gear can reach deep habitats. Noise from ships can enter acoustic worlds. Warming and changes in oxygen can alter the water column. The possibility of deep-sea mining raises questions about disturbing habitats that may recover slowly if they recover at all. These issues do not need to turn the story into alarm. They simply remind us that distance is not protection. A place can be dark and still be affected. It can be deep and still be connected. It can be unseen and still be vulnerable. The deep ocean has always seemed remote because our bodies cannot live there, but the systems of Earth do not respect that human boundary. What we release, extract, burn, discard, and disturb can travel farther than our attention. This is not a reason for despair. It is a reason for clearer wonder. To know that the deep ocean matters is to see the planet less as a surface and more as a volume. Human life occupies a thin layer of air, land, and light. Beneath the ocean's surface lies most of the habitable space on Earth, a vast three-dimensional world of pressure, darkness, cold motion, chemistry, and life. We often speak of the sea as if it were a blue surface on a map, but the ocean is depth. It has ceilings of light, corridors of migration, dark midwaters, falling particles, listening zones, ridges, trenches, plains, vents, seeps, canyons, and communities still unnamed. Its life is not arranged for human convenience. It is scattered, layered, hidden, and often fragile, in ways we are only beginning to recognize. The more we learn, the less empty the darkness becomes. The quiet surface at night no longer looks like an ending. It becomes a threshold. Below it, small animals reach. Predators follow. Living lights signal in brief flashes. Marine snow begins its long descent. A whale body somewhere in the open sea may be falling toward a future community. Vents continue releasing heat and chemicals from the planet's interior. Hydrophones receive distant sounds that may outlast the night. Everything is continuing. That word may be the key to the whole journey. Continuing, not in a dramatic way, not in a way that asks for applause, not in a way that depends on being watched. The deep ocean continues by feeding, listening, sinking, rising, glowing, decomposing, gathering, dispersing, and beginning again. It continues because life has found ways to persist under conditions that once seemed almost impossible. And because it continues, the sleeping world above is never entirely separate from it. The breath of a person in a coastal town, the plankton growing under sunlight, the whale surfacing beneath a gray sky, the fish rising at night, the carbon sinking in a particle, the microbe working in sediment, the vent fluid rising through rock, all belong to one planet. Not one simple system, but one connected system. The deep sea widens our sense of home. Home is not only where humans can stand. It is not only forests, rivers, fields, mountains, cities, and shores. It is also the black water below the reach of the sun, the cold pressure where animals make light from chemistry, the sea floor where death becomes habitat, and the vents where Earth's inner heat feeds life in darkness. To think of Earth without the deep ocean is to imagine only the visible part of a much larger body. This realization can be strangely calming. There is comfort in knowing that the world is larger than our attention. While we worry, plan, remember, regret, and dream, the deep ocean continues its ancient work. It does not erase human concerns, but it places them inside a wider scale. Beneath every restless night, there is another night deeper than ours, older than ours, and alive in ways we barely understand. The darkness below is not empty. It is not still. It is not sleeping. Somewhere now, even as these words move towards silence, a small animal is rising through the water because the light above has faded. Somewhere, a fish is dimming its body against the faint glow overhead. Somewhere, a jellyfish is flashing because something has touched it. Somewhere, a particle of marine snow is falling so slowly that its journey may outlast the night. Somewhere, a whale call is traveling through black water. Somewhere, bacteria are turning chemical energy into life beside a vent no human has seen. Somewhere, a scavenger is crossing the sea floor toward the scent of food. Somewhere, mud holds the memory of bodies that sank long ago. Somewhere, the ocean is carrying carbon, sound, heat, hunger, and time through darkness. And above it all, the surface may look calm. A person on shore might see only a dark line of water beneath the stars. A ship might pass its light small against the horizon. A city might sleep with curtains drawn and streets empty. The waves might breathe in and out with the same soft rhythm they had at sunset. Nothing on the surface would reveal the fullness below. That is the deep ocean's quiet power. It does not need to show itself in order to be real. It does not need to fit inside our senses in order to matter. It has been working beneath the world through all of human history, through all our myths, voyages, wars, maps, sciences, and dreams. We are latecomers to its darkness, but we are learning to listen. We are learning that the ocean is not a background to life on Earth. It is one of life's great interiors. We are learning that darkness can be active, that silence can carry sound, that scarcity can support patience, that death can become habitat, and that life does not always begin where sunlight falls. The world below our sleep remains unfinished in our knowledge, and perhaps it always will. That is not a failure. It is part of the wonder. As this journey closes, imagine the surface once more. The night is still there. The sea is dark. The air above it is cool. Far from shore, waves lift and settle under a sky full of distant stars. Nothing seems hurried. Nothing seems awake in the ordinary way. But below the ocean is moving. Layer beneath layer, signal beneath signal. Life beneath life, the deep continues its hidden work. The planet turns. Dawn will come to the surface. Human beings will wake, speak open doors, and begin another day. And far below that daylight in the cold and patient dark, the deep ocean will still be there, falling, feeding, listening, glowing, waiting, alive. And now, as our journey rises slowly back toward the surface, the sleeping world feels a little different. The ocean is no longer just a dark shape beyond the shore or a quiet sound at the edge of night. Beneath its surface, we have seen a world of motion hunger, light, silence, sound, decay, and renewal. We have followed creatures rising in the dark to feed. We have watched living lights appear and vanish in black water. We have seen the slow rain of organic matter falling from above, and the sudden abundance of a whale body becoming habitat in the deep. We have also seen that the deep ocean is not only a place of strange animals, it is part of Earth's hidden work. It carries carbon, it recycles bodies, it shelters life where sunlight cannot reach. It listens through darkness, responds to currents, gathers around vents, and keeps moving far beyond the reach of human attention. Perhaps that is the quiet wonder of the deep sea. It does not need to be witnessed in order to matter. Long before we lowered cameras, sent down submersibles, or listened with hydrophones, the deep ocean was already alive in its own rhythms. It was already glowing, feeding, breathing, and transforming what fell into it from above. And even now we have only seen a small part of it. So when night comes again, and the human world grows quiet, the ocean will continue. Far below the waves in cold water and permanent darkness, life will keep moving through its ancient patterns. Some creatures will rise, others will wait. Lights will flicker and disappear. Sounds will travel through black water. Somewhere something will fall from the surface, and somewhere else life will gather around it. The world may sleep, but the deep ocean does not.